Disclaimer. Please do not sit down and copy our code. Please just use it as assistance as needed. Hello everyone, my name is Aaron and I am joined here with Johnny.
How's it going, everyone?
And today we are going to be going over the homework for Data Structures and Management class. Our first homework that we'll be going over is Homework 1, Single Linked List. There's two parts to this one, and it really doesn't have to be done in Java, but so that way we can explain it better to everyone that will be watching. We will be completing the program in the Java language, along with the rest of our homework assignments. All homework assignments that we do in this series will all be done in Java, for those of you that are wondering.
Most cases you'll want to probably do Java because that's the language he's expecting on the website if they are auto-graded. But something like this, which does not appear to be auto-graded, it says even do pseudocode. You can try to write a version in Python. You can use any programming language you'd like.
So, as you said, you can do this in pseudocode, but just to make it easier, and in case you do want to have this in your back pocket for another programming assignment, we're going to do it in Java. And the way it'll work is we'll take this first chunk of time and talk about the actual homework assignment itself. The second chunk of time, we will have a picture up of our API, and we will go through that. An API is just the functions and the base variables that will be used throughout the class that we're going to use.
And any major objects that we'll be instantiating and using and constructing and all that.
And then our third part will be the actual code itself. And for that, we will go function by function and explain each function whenever we get to it in order. So, some background knowledge that you need to know is, what is a single linked list? What is a single linked list, Johnny?
So it's pretty simple. A single linked list is just a type of data, which is a way of storing information that is connected in a order. So the way he's been explaining it in class for us is he has what we call nodes, which are each individual point which you're connecting. And each node can contain one piece of information. It can be an integer, it can be a character, it can be a string, it can really be any data type you want. It can even be your own data type that you've created, or an object, I believe. That's correct, yeah?
Yeah, that sounds about right.
Yeah, so it's just a way of connecting objects, data, in order. And then the intention of why you would want it is to be able to go through that order, add things on the end, look for things at certain points in the list, and the different functions we'll be creating would help with those concepts, like finding a node, or adding a node, possibly removing a node. So,
if you're wondering what a node is, we keep saying node, and I don't think that we've actually defined it yet. You'll see this whenever we get to the API, because this will be something that will already be created in the API. But a node is basically a data value that we've created ourselves, because it's not a common one in Java. It has two values in it. It has value, which is its first thing. That basically means
whatever you're trying to store in it.
Exactly. And then the second part is called next. Next is basically an arrow, as he described it in class, pointing us to the next part of the list. So if we have three nodes and we want to link them together, node 1 would have a path to node 2, so their next would be pointing them in that direction. And then at node 2, the next would be pointing them in the third direction.
So my question then for you, I'm not sure if you know, but what would the reference be pointing to for that third node? Or would it not have one?
So for the third node, it still has to have a next because it's in the data structure that we've created. However, for that next will be equal to null. So
Gotcha.
Whenever we go through and we try to find the end of a list, we're going to be looking for if it's null or if it has an actual path.
So maybe a good way to visualize the concept in something that we've already discussed and went over in object-oriented would be something like a recursive function, which is something that calls itself and calls itself until you reach a endpoint. So this linked list is basically a recursive list because you have a value and then it calls another value, and then it calls another value until you reach a value that doesn't point to another value.
So, all right, so we're going to go ahead and get started creating the API, and you will see us back in just a second. Hello, everybody. We are back with the APIs.
All right.
So, let's go to the top and go all the way to the bottom.
Okay.
So, we're going to start with the public class. Public class singly linked list. I know it's named differently up top, but just don't worry about that too much. The biggest thing that we need to note here, though, on a serious note, is the item thing. The item thing that's in the little arrow brackets. What that is doing is that's allowing it to where we can put any data type into this object and it still be able to work perfectly fine.
It can be a linked list of strings or integers or characters or whatever you want. Objects, even, non-typical data types.
Exactly. Next, underneath that, we have private node head. Private node head is a special node that we needed to define at the beginning because that is what allows us to... I'm having a complete brain fart. Oh yeah, that's what allows us to see what's at the very beginning without having to do a get 0, which is kind of pointless.
But Aaron, they might ask, what is a node? Well, that's where we have the next one. We have a private class, which is found inside of the class, which you're like, oh no, aren't nodes supposed to be in separate files? Well, yeah, if they're public, but you can have a private class inside of a public class, and that's not a problem. I think you can even have however many you want, but we only need one. So, we have a node, and inside a node we have a few things. We have an item value, which is just a variable of the data type that you provided the public class. So if you're making a list of integers, that's something that holds an integer. And then you also have the public node next, which is a object of the type that you're creating. So it's kind of like a reference to another version of itself, which that other version is, you'd guessed it, the next one in the list. So if you have an ordered list, it's 1, 2, 3. 1 is its value, and it's referencing 2. 2 is the next node, which has the value of 2, which references to 3. And last but not least, you have the constructor, which is a public node. It's pretty simple. I don't even know if we need a constructor because it'd be default and it just have null to start, but I guess you'd want a head no matter what. But
we built it anyways because why not?
And you can have a constructor there if you want.
So
it won't hurt anything.
Our first function for this singly linked list class is going to be public void insert. What insert is allowing us to do is it's allowing us to add a node to our list with the item value of A that we're passing it. So it will automatically append it to the end of the list. There is, at least for our function, there is no way to put it at a certain index. Now you could go ahead and create one if you wanted to, but we just
didn't want to do that.
We just decided to not have to deal with that. It will be nothing that is important whenever it comes up later on. You
don't need it for any of the functions that we're doing or you need to do for this specific assignment. With Secondlast or reverse, you don't need either of those. So the next function we got on here is public item remove. This one's, again, fairly simple. You just go through the list and look at every single node. And when you find a node that matches the value item A that you provided the function, it then removes that node from the list and directly connects the node before it to the node after it, and that node is then irrelevant. And that's what that function does.
The next function that we have noted is public item get int A. Now, you may be wondering why everything else was being passed an item and this is being passed an int. That's because the function of our get function is that we are going to be pulling a item out from that certain index. So we want something to be able to access...
We're not pulling it out. We're leaving it there. We're just getting the value of it.
That's true. We're only going to be... We're throwing back what's at that index, essentially. Whenever we made this function, we were thinking about it as, well, if I ever end up using it in the future, which it's also usable in later functions, but if I ever end up using it in the future, I'm definitely going to want to be able to go through and get something at a certain index. Like an array.
Like an array, yeah.
So that's why we went ahead and threw get in there. It will also be very important later on.
Yeah. The next one is also we weren't even planning on originally having, but when we started coding, we had to go back and add this one in because we realized that we needed it. So this one's very simple as well. It just gets the size of the linked list. So if it's 1, 2, 3, there's 3 nodes, it'll return the value of 3. If there's 5 nodes, it'll return a value 5. And yeah, it's fairly simple to write. I don't think you guys would have any problems with that, but
now something that we are doing, you'll notice a red dot right next to that function. The reason why we've put the red dot there is to indicate as well that we didn't think about this whenever we were first creating our API. And so we're going through this after we've already written all the codes and everything. So that's just a heads up to you as, hey, this one might not be too entirely obvious, but once you get into the programming, you'll realize that you might need that function. So we're giving it to you now. Which,
in the API. Yeah.
By the way, while we're on the topic of these functions in general, if you would like to be able to search and scrub through and look for a certain function, we're going to have in our description, we're going to have all the functions in their timestamps. And then underneath that, we're going to have a main code that you can copy and paste into a main class and have it run with your single linked list. That list, or not that list, but that class will be using all of the function names through the API. So
you can, if you use a different API or you name the function something different, by all means create your own main class. That doesn't matter at all. We just figured it might be a nice resource to be another way to test your own code and see if it works.
Also, if you would like our sample data from what we used in our main and what we got for our main
For the runs,
we will go ahead and send that to you. Just go ahead and email us, which our emails will both be in the end card. And yeah, so I'll go ahead and do the next one, which is public boolean. Oop, there we go. This one's pretty self-explanatory. It returns true if the item passed is a variable.
It's public boolean find, yeah.
So, yeah. Basically what it's saying is, okay, is this number in this single linked list? Let's figure out. And it will just hop in between one and the next and the next. Once it finds it, it breaks out and it's like, I have it, and we don't have to search anymore. I have the Holy Grail. It's the 3. And so it'll return a true.
This function was interesting because he mentioned it in class, so that's why we chose to put it in the API and actually implement it later on. But for the functions that we're doing for this specific assignment, we didn't actually need it. So if you don't want to put it in, I guess you don't have to. But if you want this class for later use, by all means, go ahead and implement it. It could be a useful function to have. So next, after, where is it?
Right there.
Public item
last.
So this one is fairly simple. You just have it go through, and then when you hit the last node, you go ahead and pass the value back up to the main or wherever you're looking for it from. The next one is fairly similar. Public item Secondlast, which this one is the one he asked for in the assignment. And the difference between this one is that instead of returning the last node, you're returning the node before the last node. So the second to last node. Again, this one takes a little bit more thought to get through and to get past, because once you go past the node, there's no way of looking at a node like right before it, because in the node class you have the thing referencing the following node, but there's nothing to reference back to the previous node. So you have to track the previous value as well, and then go ahead and pass that at the end.
Yeah, that one takes a little bit of mental mapping, I guess you could say, whenever you're doing it. Maybe have like a piece of paper or something and draw yourself a linked list of maybe like 5 or something. And just because that will help you really plan out the process of, okay, this is what I'm doing, and then I'm going to this, and just kind of figuring out your variables really slowly, that will kind of help whenever you're doing that. Mm-hmm. So I guess I'll get the last two. Sure. We're going to start off with public void print list. That's very self-explanatory. We were given that in class, so if you're looking for a different one, we're sorry. We pretty much just use the same one. We did edit it a little bit for debugging, but we did not save that for our final one. Our final one is just printing out the list, and that's pretty self-explanatory.
Yeah.
And then the final one, I'll definitely... Yeah, it's a bugger for sure. Basically, what you're wanting to do is you're wanting to flip it or reverse it, which it sounds pretty self-explanatory, but it can be very annoying. So, we'll get more into it whenever we use singly linked lists, or whenever we actually show you how we did our functions. But it's very important to make sure that you're using your other functions properly.
Yeah.
You're using it helps a lot to use this dot, as I learned. I didn't quite know that was very as important as whenever
when you're referencing a function like by say get, you're getting a value. You want to we both found that we like saying this dot get or whatever as opposed to just saying get, because you can not have this and it'll work completely fine, but for the sake of organization, because we ended up having a second linked list that we were referencing, which was like a temporary one, it got confusing having get and then like temporary dot get, so we left it as this and then temporary dot get. So two separate ways of keeping them apart in your mind.
Yeah. So whenever we come back, we will be showing you the final class, completely laid out and done, bit by bit. We'll be going function by function, and we will be skipping over. We're not even going to open the private node class. Basically, that's just a constructor, and the default constructor there is just setting everything equal to null. So we don't think that you'll need much help with that, so we're not actually going to hit on that. If you have a problem with your node constructor, you can send it to us through email, and we can look at it and try to give you some tips.
It doesn't take much for it, though.
Not at all. So we will be back in a little bit.
Yeah.
Hello, everyone. We are back with the actual functions completed and done and ready to talk about. So, like we said earlier, we are not going to be going over the actual private class node part.
It's pretty. You can show it to him if you want to, but there's not much to it.
Yeah, it's
literally
pretty,
just setting the two values to null.
It's pretty simple, so we're not going to worry about that. But we're going to go ahead and start with the insert function. So, like we said before, insert is just inserting at the end of the list. So, the first thing we did is that we created this node called temporary, but temp.
So we set its value to whatever it was passed. It doesn't reference anything else. It's just a standalone node. We have two cases for it. We have the first case, which means it's already an empty list. And in that case, that would mean the head is null, which is the private node head, which we had referenced before. So if that is empty, meaning an empty list, you set that first node in the list to being that temporary value, which is assigned what was passed. The second case, if you want to take that one, Aaron, the second case, or if it's not empty.
The second case, or if it's not empty, it's going to make a new node, current, that's equal to head. The reason why we're not using constructor there is because it's like assigning a variable. So it's setting, since it's the same data type, we're able to
Both
set
nodes.
We're able to set them equal to each other. While current.next is not equal to null, current is going to equal current.next. Basically, all that that's saying is that, okay, while we're not at the end of the list, we're going to copy the next path and try to get to the end of the list. Once we get to the end of the list, we're going to assign that next to temp. What that allows us to do is, back here, whenever we had the value set to A, that means that whenever the next is set to current, we're completely done.
So you're, at that point, you're just adding that node onto the end of the list.
Exactly. So that that else statement is what's getting us through. But
Yep.
what's very important to note, if in case you didn't figure it out, what is actually iterating us through is current equals current.next. And that's what's allowing us to move from node to node, in case you might have been confused or
So
disturbed.
it's setting current to this from the first to the second node, and then checking if that's the last node, and then if it's not, it'll move to the third node, see if that's the last node, and so forth until it gets to the end of the list. That's pretty much it for insert. If you want to move on to remove, so if we check out remove here, we have two nodes that we're creating here. One is the previous node, and one is the current node. They're both initialized to the same node, which is the head node. But as you see when we start moving through things, they do keep track of two separate nodes. So, and we also have a variable called found, which is a Boolean value letting us know if you found the item that you want to remove or not. So,
yeah, so the first thing that we want to do is we want to set a default case if the head is the end. We had a little bit of a problem with this whenever we got to
the reverse.
So what we ended up doing is if head.next is equal to null, which means if the head is the only node in our single linked list, we're going to make the value null. What that essentially does is
it removes it and makes it an empty list.
Exactly.
Yeah. And then if that's not the case, if there's more than one thing in the list, we don't have to worry about it, and we go through with our main while loop. So this one, we take the current node, and if it's not null, then we check the value and see if it's equal to what we're looking for, which is A. If it is, it sets found to true, breaks out of the while loop, and then we'll get to that in a moment. If it's not true, it then sets the previous node equal to the current node, and then sets the current node equal to the next node, which is just a way of moving both of them up.
It's very important to note whenever we're using our break statement that breaks don't break you out of if. They break you all the way to the first loop that it finds. So break will only break you out of a while loop or for loop.
So it goes all the way to the end of the for loop right when it hits that break statement. And then what it does then is it goes to the if, and it'll it'll go through and it'll say if it's found, which it is in this case because we set found to true and it broke out of the while loop, then it goes ahead and sets the previous .next equal to current .next.
Yeah. And so this next one's pretty easy. It's the get function. Basically, we're passing it that int a, and we want to get the value of the node at the place specified starting at 1.
Think of it like a index on an array.
Exactly. So what we're going to want to do first is we're going to want to make our own node that we can use to pass through the entire actual index.
Through the entire list.
That's right. So we're going to start count at 1 because we want the counting for this entire program, for us at least, to start at 1. We're also going to make item found equals to null. So this is very close to the Boolean one that we'll find later on.
Yeah.
While our temporary is equal to null, and if the count is equal to the index that we're at, we are going to make found the value at that. Basically, all that's saying is fancy for, okay, while we're not at the end of the list, and if the value that we're at right now...
The index is the same as the index we're looking for.
Exactly. I shouldn't say value. While the index that we're at is the index that we're looking for, found will then become the value at that index.
And then you break and escape the while loop. And if that is not true, if you're not at the right index, you increase and you move on to the next node, and you also increase the count variable, increasing what index you're looking at. And then at the end, you return found, which, again, is the item type specified at the very beginning. So whatever type of list you're creating, it's that same type of item because it's whatever value you have inside that node and the list. So next we have the public int get size. This one I'm going to say is probably the easiest or simplest one here.
Probably.
Again, it's very similar to the last one. We're creating a node which starts with the same head as the list that we're going, or the main list, I guess. Int count equals 1. But in this case, we're checking if the next value in the list is not null. As long as it's not null, meaning you're not at the end of the list, you go to the next one and increment count, and then you return the count variable at the end.
They're pretty much the simplest function we are going to get to in today's list
You
of
go
functions.
through and you count the number of nodes that are there,
So
and it returns it.
our next function, that this one is the one that we said is not important. It's not one that we use later on, and it's also not one that he requires, but we threw it in there because we thought it might be useful if we end up using it later.
In class.
And he mentioned it in class. So, as I said, it's going to look very, very close to this get function, so I'll just go ahead and open them both up at the same time. So, as you can see, we're going to have a temporary head, or we're going to make head temporary equal to the head node.
Mm-hmm.
That's kind of a mouthful. But we're going to have another found variable, and this one's going to be Boolean, though, and it's going to be false. The reason why it's going to be false is because if we don't end up finding it, we don't have to change the value of found. It can just stay false.
And then the trigger for the while loop is exactly the same. If the temp is not null, then inside the while loop, instead of checking the count, we're checking if the value is equal to the one that we're looking for. And if it is equal to the one we're looking for, we set found to true, break out, and return true. If you never hit that, it'll just increment all the way through, and then nothing will happen. Actually, should we have it return false?
It will.
It will.
It will
yeah.
happen.
I just realized that because it's set to false already, and will return found at the end. Yeah.
So
it will return false if it never hits the number that you're looking for.
this is a true
A.
statement.
So again, that one's pretty simple.
Now we're going to start getting to, well,
This one's not too bad.
This one's not too bad.
I'll take it again. This one, again, we're creating a temporary node starting at the beginning of the list, which is the head. We're creating a value variable, which is of the item type provided at the beginning. While that temporary node is not empty, while it's not null, you check if the next one is null. So if the next value is null, that means you're at the end of the list. And then you take that value at that temporary point and set the value variable equal to it. So value equals temp.value. You break out and then return that value. Again, a very, very similar layout to find, but it's just different things controlling the if statement and different things you're returning. You're looking through counting, you're looking through to find, you're looking through to find the end. You're just looking for different things while parsing through the entire list. So after doing all of these functions, you'll be very familiar with how to parse through a single linked list.
Correct. So now we're going to go ahead and get on to second last. This is a little bit more complicated because we are going to have two nodes going at the same.
Well, we did
didn't.
it kind of different. We didn't have a second node. We just
That's right. Okay.
have a value variable.
So we have node temporary, which is going to be equal to the head, which is our beginning. Then we have an item last value, and we set that equal to null, because if you think about it, what's behind the beginning node would be absolutely nothing. So we decided that, well, that nothing can be represented by a null.
Yeah.
If
So
temp.next, which is the path from the head, is equal to null,
that means it's only one node, which is a special case, which is why we have this here. So if it is only a one node or one item in the list, you simply return null. Because there is no second last variable or second last value in a list of one. That's a non-question. That's a stupid thing to even ask for. So we just return a null in that case.
If that special case is not true, we are going to go one forward and get temp.next.
Set temp equal to temp.next, yeah.
While temp is not null, which basically means while we're not at the very, past the end of our list, if temp.next does end up...
So if the following one is null...
Yeah. And the reason why we have that there is basically just to keep it from running this line at the very, very end.
Yeah.
So basically what's going to do is it's going to keep iterating through until we hit...
Until you hit the end, but when you hit the end, the value stored in the variable named last value is not the value of that last node, but is instead holding the value from the node before it, and it never got to update to the newest one.
So that's the reason why we're using the if and then the break, because that keeps it from... That allows us to test that before we hit the value.
Now, I believe there are other ways of doing that instead of using a break by doing the ordering of the assignments differently.
And of course, there are different options to pretty much everything that we're proposing right now. These are just the ones that we came up with. So if you came up with something else, that doesn't mean you're wrong. We're just showing you what we came up with.
Which probably isn't even the best way of doing it. Who knows?
Probably not.
But now this one again is the print list. He did this one in class. It's pretty simple. You just set a node equal to the first one. We did 2 lines to separate the output, make it look a little bit nicer. And then while the current, or the temporary, you could call it whatever you want, while that node is not empty, go through, print it, set it to the next one, go through again, print the next one, set it to the following one, and keep going until you're done, print out another line. It's pretty simple, makes it look nice on the screen.
Yes,
and
it's
yeah.
very... The print list one is very helpful, especially for the debugging.
Yes.
Which we had to use a lot of for this next function, public void reverse.
Here we go. This is where...
If we're going to be honest, this probably took us 2.5 hours?
Yeah, about 2.5 hours.
So...
We tried many, many things. So if you were trying to work on this one and couldn't think of it on your own... We're right there with you. It took us a long time to get there. We were about to call multiple people. We even considered calling Barrera on this one, but we ended up getting it working on our own. And we believe you guys could too, but we're here to help if you want.
It was absolutely glorious whenever we finally figured it out.
Oh, yes, we celebrated very much.
Oh, most definitely. The biggest thing that we did here that might confuse you is that we created another instance of a single linked list.
Mm-hmm.
That is probably the most confusing part out of all of this, especially because we still have to make this general, so we're still using item. That might confuse a lot of you, but basically all that we're doing is saying, okay, we know that we're writing this, but we're not going to be using the actual reverse function in the reverse function definition. So we can use all of the other functions that we've used so far and use it as like a second thing to copy over from.
Okay, so I want to, before we go line for line, I just want to do a brief explanation of what actually is happening here. So what we're doing is creating a secondary list, which is temporary. Then all we do is go through and make it, we turn that new list into a copied version of the original list, but backwards, which is what happens in the while loop. And then after that, we go into the for loop, and we use the for loop to convert the actual main list that we're working with and making that a copy of that temporary reverse list. So that's how it actually does the process of reversing the list that you're trying to work with, because we could have done it so it actually returned a new list, but we'd rather it work so that you're actually reversing the list you're giving it.
Yeah, and so basically, to dumb it down even more, the while loop is basically reversing it and putting it into our new list. And then the for loop is just copying everything that we got in that new list and changing it to the original list that we have so far.
Yeah, changing the original list to match that.
So I guess I'll go ahead and take the while loop and explain that, because that's fun. So the first thing that we did is we had a value and we made it equal to null. And then while this.head.value, this is what we were talking about with the this, and that it's very helpful, especially in this part, since we're talking with 2 different lists.
So remember, this, the word this, means the main list, the main list that we're working with, and the other list is called temp list. So you'll see we also have temp list.insert, we have this.remove. So it got really confusing with using the different functions with the different lists. So keep that in mind, that this is the main list, temp list is the temporary list.
So basically what we do is we say, okay, we want the value of our last number for our original list. So this dot last. We then are going to take our temporary list, which is what we named it, in line 165, if you guys can read that, and we inserted it into there, because the insert function appends to the end, but our temp list is completely empty. So our last value is going to end up being the first value of temp list. Then we're going to remove our value from the original list, which means it will go through and check to find that variable or value. Sorry, it'll check to find that value, and then remove it from the list.
So again, to say it simply, it takes the node at the end of the main list, puts it at the beginning of the temporary list, and then removes it from the main list.
Yes.
It does that from the back. So say there's 3 nodes in the main list. It takes number 3, puts it at the beginning of temporary, takes number 2, puts it in the second place in temporary, takes number 1 from the main, and puts it in the third place in the temporary. So at the end of the while loop, the temporary is a reversed version of the original, and the original list is now empty. And then what happens is we have 2 variables. We have int I, which is templist.getsize, which is why we ended up needing that function, as we mentioned that earlier in the video. It gets the size, which is the number of nodes in the temporary list. And then we have j, which is the control variable for the for loop. So we set it to 1, while j is less than or equal to I, we have to do plus plus j. And that took us a while to figure out, because if you remember, there's a difference between plus plus j and j plus plus, which we learned that last year in OOP. And in this specific case, we had a lot of problems trying to do j plus plus. So switching to do plus plus j, it does the addition at a different point in the loop, which changes how a lot of things work with things, and it works better having plus plus j.
Correct. So in our actual for loop, we are getting the value at the temporary list spot of j. This is another reason why we wanted to have it start at 1, is because then all of this would be very succinct and similar, because Getsize also starts at 1. So this just all ended up working out really nicely. So it gets the value at temp list of j, which our first case would be 1. If j is equal to 1, then our head value is going to equal what our current value is, which is being assigned right above it. Basically, that's just assigning the head again. It's nothing that terribly mind-boggling.
The only reason we have to do that is because doing this.insert, when you're trying to insert into an empty list, it didn't work. It didn't want to actually create a new head value. It left the head null and then added a new node in the second place. So what we had to do is, in that first case, where j is 1, you have to set the head's value, because the head was set to null, and it didn't want to change that by just simply doing insert.
Yeah, because if you remember with our remove function before, we were saying that if head is the only thing there, it sets both the value and the path to null.
But it's still actually a node there. It's only a list of an empty node, which is why we have to have that case, because removing the head is impossible. You just set it all to 0.
Exactly. Then we're going to do our else, which is if it's not equal to 1, it's just going to insert it into the new list, which is pretty much
so it'll take the main list and set it back to that value at that point.
But yes, this function took us about 2...
It doesn't look too nasty, but it took a while. But
it took a long time for us to figure out that we could use a singly linked list again.
We could. And also
plus-
the idea of doing a while and a for loop in that order, I think using that plus the idea of using a new list, that is enough to get you in the right path.
Yeah. So, as we said before, we will be putting our main function. If you would like to test this, we'll be putting that in the description below the timestamps. So if you would like to go in and have something to test it with, you can go ahead and use that. If you want the sample data, we can go ahead and give you some sample data and sample outputs.
Email us and we'll...
Go ahead and email us, which will be in the end card.
and the description, probably.
Yeah, maybe, if there's enough room. But yeah, that's pretty much all that is done for this programming assignment. If you guys have any questions, like we said, feel free to email us or go ahead and post it in the comments before.
Yeah, we'll try to look
below.
at them.
We'll try to look at them.
Before the homework is due and get back to you guys.
Other people will try and look at them probably.
Yeah. Oh, and if we are planning on doing videos similar to this for homework in this class in the future, and possibly even other classes, maybe, who knows, but if you think you'll want more help in similar type of assignments in this class, go ahead and subscribe, I guess, and we'll keep getting some help out for you guys.
And if you guys have any feedback to make this these videos even better,
or more useful, what
please
do you think? Yeah.
let us know, because we know that these videos are long. We're already at 42 minutes, but they kind of have to be just because the amount of material we need to go over. So sadly we can't make it any shorter, but if there's anything else that we can do, please let us know. So
Other than that, and we'll see you guys in class. Have a nice day.